Okay, so it's a short semester at the moment. Should I start then you introduce one of our speakers or
I can.
or do you want to introduce
I think I need more speakers.
Why don't the speakers are whatever you know actually.
Yeah.
So maybe we introduce first.
Okay.
Then I'll introduce Anna and then we introduce us.
Do you have like introduction you
Oh,
yeah. Okay. That's very much what I'm saying. Okay. Yeah, it's fine. I'll say stuff. Okay, so we are broadcasting to YouTube already. So anything getting picked up on that one is okay. In theory. If we get comments that say we can't hear anything, then we'll fix it up. Yeah. We're missing the comments.
Start. Hi everyone. Okay, is that any better? No. How about that? No. Hi everyone. Thanks for coming. It's the 6th year we've done this competition. It's also the first in a long while when we've had an actual physical ceremony. So I guess I can't say that it's historic that we're here, but first time in like, it happens like half the years, given that it's been 6 years and we've missed 3. So I'm sure you're all sort of more interested in finding out where you came and where your kids came and so on. But we are going to start with the speeches. And we'll begin with a welcome address from our Assistant Dean of Science, Prof. Willem Conradi, who's a logician in the mathematics department. Prof, over to you.
Thanks, Jonathan. So welcome, everyone. It's really great to see everyone here, all the participants and prize winners, the parents, our sponsors, academics. There are a lot of people who contributed to making this event possible. So as Jonathan said, I'm Willem Conradi. I'm the Deputy Dean in Faculty. Our Dean, Professor Nithya Chetty, would have been here. He normally is, but he's currently in Nigeria, where he's working on the setting up the Afritech network, which is a network of universities across Africa working towards improving science and technology on our continent. So I know he's very passionate about this event. He's a physicist himself, but he always emphasizes the importance of mathematics in science and society. So he would very much like to have been here. So I've been talking to John a bit, and I'm really impressed at how this competition has grown. When I joined Wits in 2018, I was sort of tangentially involved in this competition. I think I gave a talk on some mathematical puzzle when the competition actually took place. It was in Flower Hall, it was huge. But at that point, we had about 900 learners from across Gauteng. In the meantime, this competition has grown to the point where we had this year 11,000 entrants from across all South African provinces, and also some foreign participants from Nigeria, Liberia, Rwanda, Namibia, and Botswana. So I think it's really amazing the enthusiasm for mathematics, the Wits Mathematics competition itself, and how this has grown over the years. As you know, the competition has 5 divisions. There's a junior and senior, the middle primary and the upper primary, so junior and senior in primary school, and then a junior and senior secondary school division. And then also we have a division for undergraduate students, so the first 3 years of study. So I am a mathematician myself, but as we all know, mathematics is absolutely fundamental to all the sciences and technology. And these are really some of the major forces driving our world at the moment. So, of course, most of the sciences are empirical or experimental, so observing phenomena in nature, forming theories based on this, formulating hypotheses. So this is so-called inductive reasoning. But mathematics, as we know, is in a sense the conceptual language in which we formulate the theories and the models built by the other sciences. But it's also the deductive engine of the other sciences, whereas we make inductive steps, not in terms of mathematical induction, but in terms of scientific induction, from observed data to theories. We also need deductive reasoning to deduce hypotheses that can be tested from these theories to ultimately verify or modify or reject them. And that is really where mathematics is absolutely fundamental and key. Now, of course, we know South Africa doesn't perform that well in terms of the international evaluation of mathematics. And that's, of course, a great worry for us at university. But that is why I am so glad to see so many of our brightest young mathematical minds in the country here tonight. You really give us hope for the future. You know, you really make our jobs worthwhile. So welcome again here. And you know, the average student complains about mathematics, but you guys see the elegance, the beauty, the thrill of mathematics. So it's really nice to be here among fellow mathematicians. A lot of people were involved in making this competition possible, and I'd like to name a few of them. First, our sponsors, Allan Gray and Sharp. We would not be able to do this without you. Thank you very, very much for supporting this competition and our young mathematicians. It means an awful lot to us, to our university and to our country. Then the people who are involved in setting the papers. I mean, there's a lot of papers that need to be set for this competition, and that's no mean feat. Setting a good Olympiad paper is a delicate piece of work. I am involved in setting the SAMO senior first and second round papers, so the National Olympiad. So I know, I mean, we're currently busy with the paper, and it's a long process of judging the questions just right, finding things that are going to be exactly on the right level, but are going to be interesting and challenging. So the people involved in setting the papers for the Wits Math competition are Jacques du Plessis, Graham Evans, Bianca Fourie, Callan Kotson, Phil Labuskaghni, Malwanda Nkonyane, Dylan Nelson, Evan Snyman, Clint van Alten, Veronica van Rooij, and Jacqueline Venter. So thank you to those people who ultimately drive the very engine that makes this competition possible. Then we had some of our math students at Wits who helped to review, and other people who helped to review these papers and helped with the administration. So I'd like to thank Alex Vogt, Asha Hodge, James Flowers, and Abuza Rukmanji. Then we have a number of our academics who have been very deeply involved in the competition. Professor Betsy Jonk, Professor Musa Manzi, Dr. Pravesh Ranchod, and Dr. Jabulani Pakati. So thank you to them. Carl Ginster helped with software development for the competition. We have an ethics committee involved here. They consist of Tyron Greenwood from North Dakota State University, Liam Baker from Stellenbosch, and Andrew Obers from Baruch College in New York. I'd also like to give special mentions to Ruben, Kuno, and Khomotso. And then the regional coordinators, of course, this is across the country, so those logistics are quite involved. So I'd like to give a shout out to the regional coordinators, Linda Emery from the Eastern Cape, Elsie Schoonby from the Free State and Northern Cape, Graham Evans from KwaZulu-Natal, Ibrahim Simsek from Limpopo, Lazan van der Merwe from Mpumalanga, Kala Hutton in Northwest, Phil Labuskaghni in the Western Cape, Matthew Masole in Botswana, Daniel Akontoye in Nigeria, and Aubrey Gogosev in Namibia. Thank you to all these people, and thank you to all of you for being here tonight. Please enjoy the award ceremony.
Okay, thanks, Prof. Always good to, yeah. It's my fever. Okay, so by tradition, we typically have two speakers, one international and one local. Our international speaker is Dr. Ashley Hutchinson, who came up through the Harvard system, did a PhD here, lectured, and was stolen by Cambridge, and I believe has now moved to the University of Manchester. She will be joining us remotely. Yeah.
Hi, can everyone hear me? Testing, 1, 2, 3. Oh, okay. I hope everyone can hear me. It's a little bit daunting giving a presentation online. Oh, no, you can't hear. Okay, well, I can change slides. Let me see. Can you hear me now? Testing, 1, 2, 3. Hello? Testing, 1, 2, 3. Um, hello? Okay, just 1 second.
Check if anyone can hear you.
Can you hear me now?
Yeah, it's picking it.
It-
Oh, you know what? It's
Oh.
clashing with that.
So what would be the best?
Um,
Do you think it is clashing with that?
yeah. So let's do this. See if that works now.
Can you hear me now? Testing 1, 2, 3. Yes, they can hear me. Okay. Let's just put the camera back. Okay, can I, sorry, get a final test that everything's working? Testing 1, 2, 3. Hello? Oh, we can hear you. Okay, so can you still hear me now? Yay! All right, okay, so I can start. Can you also see me? Um, okay, I'm assuming everything is still working fine. I haven't had confirmation just yet. Right. Okay. Thank you so much. I had to call in my technical assistant, who happens to be my husband. All right. Hi, everyone. It's unfortunate that I'm not there to see you in person, as I really would have enjoyed that. So just a bit about myself. My name is Ashley Hutchinson, and I was actually born in Johannesburg. I did my PhD at Wits, and I worked there for many years. So Wits is very, very dear to my heart, and I miss it very much so. I then got an opportunity to move to Cambridge University in the UK, and I'm now working at Manchester University. So today I'd like to talk to you about my research, which falls under the umbrella of fluid mechanics modeling. I just want to start off this talk with one of my favorite quotes by Isaac Newton. And I feel that this quote is just so incredibly profound. Isaac Newton made massive contributions to the fields of mathematics and physics, though in his eyes, he felt that all of his discoveries and great contributions were merely just diversions, such as picking up pebbles and shells on a seashore, whilst not even touching into the ocean of truth that was right in front of him. This is an incredibly powerful statement because it really means that there is still, to this day, so much in the world that we do not understand. And this should excite us into action to figure out how the world works and also how we can make it a better place. My research is to do with fluids, so I'm actually more interested in diving into the ocean in the literal sense. Of course, a nice holiday would be great at the moment. Winter's coming in the UK, but I'm interested in, for example, the actual ocean, which is a large body of water. When we look at the ocean, we might imagine that we can see ships that have these wake patterns forming behind them as they travel over the surface of the ocean. There's also waves and tidal currents. And if you look beneath the surface, there are so many interesting things happening as well. So what I'm really interested in is, what are the laws that govern bodies of water such as the ocean? Or how do I describe the way in which the water flows? Why, in some cases, does it become more chaotic? And in other places, it seems to be smooth and ordered. So these are the type of questions that really excite me. So I'll start off easy. I'm sure you've been using your brains quite a lot. So from school, you would have classified matter into 3 different phases. That would be solids, liquids, and gases. If we look at our everyday experiences of, let's just say, a solid, what we would notice in some cases, or in most cases, we can actually deform them. But in general, they do not have the property that they flow. And if I had to place a rock in a container, it would not spread out to fill the container and displace the air. Now, if we look at a liquid, liquids are different in the sense that they appear to flow, just as water flows down in a river. Or we can pour a glass of water into another container. Those are the characteristics that we associate with liquids. Gases are a little bit more tricky because, in a sense, we cannot necessarily always see them. But we do know the effects of gases. For example, wind. We know that wind flows from a high pressure to a low pressure, and we can feel its effects. So we know that there is something that's physically there. What I'm concerned about really is liquids and gases. There are many interesting topics and research areas that deal with basically the transition between liquids and solids. So you get some substances that can behave as solids under certain conditions, but then under others, they can actually flow as liquids. So do not think of matter as in these discrete categories. This is all a continuum, and they blend into one another. All right, so here's just some general questions, the type that I like to ask myself when I'm doing everyday activities. And hopefully these type of questions will get you thinking, or perhaps you've already thought of all of this. Simple questions. Why does my hand come out wet when I stick it into a pool of water? From what we see and what we notice is that it appears that the water sticks to our hand. If I had to put my hand in a bowl of syrup, for instance, I would notice that the coating of the syrup would be much thicker than what the water would have done. Why is that the case? What are the properties of the fluids that we're looking at that actually lead to these differences? Another seemingly obvious question, why do some objects float and others sink? Now, you might just say, well, I mean, that's just the mass of the object. But it's actually more than that. How great does the mass have to be? And if something sinks in water, will it necessarily sink in some other medium? Those are interesting questions that have answers that we can address. Why do ripples form when I throw a pebble into a pond? As a kid, I used to love throwing stones into ponds and breaking the calm surface and watching these ripples form and then dissipate as they move further from the source to where they were generated. Another fascinating question, and I spent my PhD working in problems such as this. Why do nice smooth flows sometimes become chaotic? Here's a beautiful image of smoke coming from a candle where we see we've got this nice smooth flow, but then all of a sudden, for no apparent reason, it starts to become chaotic. Now, with fluid mechanics, we can answer questions such as, how long will it flow as a smooth, ordered substance until it starts to display this chaotic behavior? And then we can actually use probability and statistics to look at this chaotic behavior to try to predict the average behavior that we would expect. So this is what fluid mechanics is, and it's always best just to use the Oxford Dictionary. We don't tell Cambridge that though. So what is fluid mechanics? It's the study of forces and flow within fluids. Just in simple terms, from what I understand it more as, it's really a branch of mathematics and physics that falls under what we call mathematical modeling. And it's mathematical modeling, is all about using maths to solve real-world problems. Okay, so just some more everyday examples that I hope you'll actually play around with. And these are the type of things that we can model using fluid mechanics and actually understand really well. For instance, if you got syrup pouring from a spoon, you'll notice that the strand of syrup actually thins as it gets closer to the surface onto which it's being poured. But also, you actually get the circular motion as well, and you see the strand actually rotating. Why does that happen, for instance? If I'm making a lovely, I don't know, batch of cake batter or something delicious, usually these are quite thick material substances. If I have to stir them rigorously, I'll notice that it moves, but if I have to stop stirring, the fluid actually comes to rest really quickly. This is different to if I had to repeat this experiment using water, for instance, where water would take a much longer time to actually slow down. And again, I don't know, there's just something about ripples. Maybe it's the geometry and the symmetry that's just so appealing. But here's actually an example of, this is a droplet that's hitting a surface. But in some cases, under certain very specific conditions, you get droplets that can actually bounce on the surface of a fluid due to the effects of surface tension. It's really incredible. You can determine how many times that actually bounces before it impacts with the fluid below. Okay, so this is all very interesting, but I haven't really mentioned how this is helpful in the real world, even though I think food is really important and anything around that. But anyway, so let's look at some examples in nature. There is a huge body of research done on flows down slopes, and this is applicable to things such as lava flows and mudslides and avalanches. And the physics that govern these three very different processes actually share quite a few similar characteristics. So here's a stunning picture of a lava flow. As you can see, you get these beautiful ripples on the surface. Questions you could ask: how close are the troughs of these? Why are they that distance apart? Would I see this in any other kind of fluid? But from a more practical point of view, you would probably like to know how far these flows would actually travel. So for instance, if you're looking at a place where mudslides are frequent, what you want to ensure is you don't want to build any houses or infrastructure within a location where the mudslides will actually hit and cause destruction. Now, mudslides are actually really complicated because there are so many different components and what's happening in there. So if you have a mudslide with fairly dry granular particles, that won't travel as far as if you have something that's saturated with water, for instance. And it's not just because of the weight behind what is forming, it's also the fluid that causes reduced friction, which allows motion to travel for far longer distances. So these are all really important to understand, especially when it comes to policy and decision making as well. Oh, okay, industry, of course. So, of course, I'm going to choose something about electricity because what controversial topic isn't fun, right? So, wind farms, a collection of windmills that are placed in a specific pattern. Now, by understanding fluid mechanics and the flow that goes past these windmills, we can better understand how to design these structures and place them in the optimal arrangement so that we get the maximum energy output. It's a really interesting process. This is not the only place in industry that we can do this. There are many. Another example that I really like are fisheries. If you're designing a fishery, there are some fish that cannot survive in very turbulent waters. So you don't want to design an artificial structure where you've got shallow water with lots of rocks, for instance. You're going to generate a lot of turbulence. So these are all really simple. Well, so I say simple, they're not, but I don't want to scare you off the topic. So, I mean, it's really fascinating. These are all things that we can answer and address. I did want to just put a slide, which may put a bit of a damper on the positive nature of the presentation, but what we do and the consequences it has, we really need to understand that. So what sometimes happens is that in optimizing one problem, we might actually cause issues somewhere else. So this is actually a result of the wind farms. And what happens is that certain bird species, they use the lift that's generated from the flow past the windmills to actually launch into the air. But often what happens is if the windmills are too close together, this bird species can then hit the windmill behind it. So in optimizing energy output, we might actually be also encouraging these kind of situations to happen. It's just something to be aware of. I hope I don't need to state the importance of preservation of the environment. Okay, so this sounds all really cool and interesting, at least I hope, but you might be asking, well, are you just saying that you can solve all these problems? What is this really about? And I can tell you a little bit about the approaches on how we model fluids. So how we describe them mathematically, basically. Now, the tools that you would have learned in school would not equip you for this. So what I've done, whether this will be exciting or more daunting, I just put like a small snippet of one of the equations. This is really just a small section. So you can definitely see at least that there's a sine theta. So that's just to, note that all the stuff that you do with trigonometry, you will use that one day. I do promise that. But how do we go about modeling these? It's actually rather complicated. The equations are long, very difficult to solve even in the simplest of cases. But in nature is governed by laws, and they cannot defy these laws. And those laws are all centered in conservation principles, such as conservation of mass and momentum, including linear and angular. We know that, for example, mass cannot be created or destroyed, or energy, and hopefully you might have seen some examples about the conservation of momentum. If you haven't, then hopefully this will just get you more excited. So it's all rooted in physical principles. Everything is, it has a purpose. It has laws it needs to follow. Okay, so what can we actually do with these laws? Well, what is really great about fluid mechanics is that there are many different ways to approach a problem. The three ways that I focus on mainly are theory, experiments, and computers. So theory, for instance, would be developing the equations, finding solutions that you can write by hand. But sometimes you can only do that under very specialized, cases. But with whatever theory we come up with, even if it is rooted in physical principles, we don't actually know if we're right or wrong until we've tested it out. One of the ways you can test this out is by running some experiments. So I put an image on the left-hand side and the right-hand side of two experiments that I've done in the laboratory. And basically what happened is I had a theory that I wanted to test. My theory was rooted in good physics, as far as I knew. And I thought that when I do my experiments, apart from some errors, everything should match up and all my predictions of the theory in the experiment should be the same. But that was not the case. And that is when science gets really exciting. It's actually when you're wrong, because it means that there is something more to the story that you have yet to discover, and the chapter is not finished. So in this case, there was actually a physical mechanism that was of great importance that I hadn't initially put into my theoretical model. So this is the whole process of science. It's updating your thinking and reevaluating your models and learning from them. And of course, in this day and age with computers, there are some really exciting developments over here as well. We've got machine learning and robotics and really, really cool things happening. And of course, this can also feed into fluid mechanics. So I don't know if many people are aware, there's quite a famous meme about wind flow past a cow. But what was done here was actually a simulation where, they were looking at wind flow past a cow. And if you can do theory experiments and use computers to solve a problem, you actually really have a solid foundation and probably some great solutions coming in there. Okay, so you don't have to take my word for it. I would like to just end off with a quote from one of my third-year students. He says, "Fluid mechanics, it's a solid subject." And I really do believe that. So hopefully some of you will be encouraged to pursue this amazing career path. Thank you.
this. Cool. Should be okay.
Yeah.
Let me just move this slightly like this. I think we're good. Okay. Thank you, Pravesh, and thank you everybody for for being here tonight. I'd like to thank John who's given me the opportunity to speak tonight. I actually knew Ashley when I was still a postdoc here at Wits, and glad to see her online. And her talk is my talk is going to be very different from her talk. So you've seen how mathematics is useful in studying nature. But what I'm going to talk about is slightly more theoretical. So I am working in a field of functional analysis, but that's not what I'm going to talk about this evening. I have a side interest in history of mathematics, and tonight I want to share a piece of history that is very important in mathematics. Okay, so my title of the talk tonight is Fermat's last theorem. This is mainly based on the book by Simon Sink. I have the cover of the book up there. If you've read the book, you probably know about 80–90% of the talk, so I hope I won't bore you. But if this is the first time you're hearing it, I hope we're all actually going to learn something. Okay, so we'll start with something very, very familiar. Okay, so this picture, I think all of us know it, right? The moment I give you that picture, you know what's happening. It's Pythagorean theorem. We have a squared plus b squared is equal to c squared. So if I collect these three integers, whatever that satisfy a squared plus b squared plus c squared, we're going to call this triple a Pythagorean triple. Okay. A very easy example. You remember this when you first time seeing it in school, right? I like number 3, 4, and 5 because then I get nice perfect square. 5, 12, and 13. That's not a favorite, right? So we are interested in numbers, integers that are like this. Okay. So there are infinitely many such triples. Okay, this Pythagorean triple is actually an instance of solutions to a particular Diophantine equation. What is a Diophantine equation? It is a polynomial equation. So the equation involves some polynomial, maybe x cubed, maybe x to the 5, and so on and so forth, such that only the integer solutions are sought or studied. Okay, easy example is the linear Diophantine equation, ABC satisfying AX plus BY equals C. Oh, sorry, I should say two numbers that satisfy AX plus BY equals C in place of X and Y. Second example, the equation x squared plus y squared equals z squared, whom you know the solution from the previous slide, is there are all the Pythagorean triples. Okay, I give you this other equation, w cubed plus x cubed equal y cubed plus z cubed. The smallest non-trivial solution, by that I mean all the integers are not 0, is 12 cubed plus 1 cubed equal 9 cubed plus 10 cubed. This is 1,729. Does anyone know a name for this number? Maybe someone in the audience? Yes? Taxi cab number, thank you. Yeah, this is called a taxi cab number or Hardy-Ramanujan number. Yeah, this is the smallest number. The story goes that when Ramanujan, he was discovered by Hardy, and they were in England, and they got into a taxi, and he saw the serial number of the taxi, and he said, hey, that's an interesting number. It's the smallest number that can be written in two ways of sum of 2 cubes. Okay. So, Diophantine equation is quite old. They were found in the ancient Greek text Arithmetica, written by Diophantus, 3rd century AD. I took that picture of the cover of some edition of Arithmetica from Wikipedia. And the person's name who appeared in the title of my talk, Fermat, was reading Arithmetica. So on this particular problem, he said that there's a theorem. So he wrote that he thinks this statement is correct. He wrote it in the margin of the copy of Arithmetica that he read. So imagine you're reading a book, you're writing it on the margin. Then he wrote this theorem, which later going to be known as the Fermat's last theorem. And he claimed that he had a proof, but the proof was too large to fit in the margin. So he didn't write it. Okay. So this is an image that you can find on Wikipedia if you look at for Arithmetica. This is already including the comment by Fermat. Okay, so what is the theorem that he wrote? This is what he said. The equation x to the n plus y to the n equals z to the n. So this looked like the Pythagorean that we saw earlier. Instead, the exponent now can be any integer. And he claimed that this equation has no integer solutions for n greater than 2. Okay, but as mathematicians, we only call something a theorem if we have a proof for it. So at this point, we haven't seen the proof, so we can't call it really a theorem, maybe a conjecture. Okay, so his proof was never found. A lot of historians actually think that he never actually had the proof. Who knows? Only one relevant proof by Fermat was found for case n equals 4. So equation x to the 4 plus y to the 4 equals z to the 4 has no integer solutions. Later, Euler, another famous mathematician, adapted his proof and showed that x cubed plus y cubed equals z cubed has no integer solutions. Okay, so we're making progress here. We show for 3, we've shown for 4, but we still have to show for exponent 5, 6, 7, and counting, and counting, and counting, many of them. Fermat claim is for all n, all possible integers. Okay, but situation's not too bad, right? Because if you have proof for n equals 4, you have proof for all multiples of 4. Why is that? Well, any 8th power, 12, 16, and so on and so forth, you can write it as a 4th power, right? So for instance, the number 256 is 2 to the 8 or 4 to the 4. Okay. Similarly, using Euler's proof, you have proof for 6, 9, 12, 15, and so on, and so on, and so on. Oop, something's going on. There you go. Really important because 3 is a prime number. Why do we like prime number? Mathematicians, particularly number theorists, like prime numbers because they are the building blocks of numbers. So the proof for the theorem will be completed when one can prove for all the case of prime numbers. Why is that? Because any other numbers are multiples of some prime number. Right. Okay. So if we can prove for all prime numbers, then we're done. So our task has been reduced to proving this one, this one, this one, and so on. I have bad news for you. There are infinitely many primes. Still too many. Anyway, so let's talk about the attempts to prove the theorem. From 1637 to 1839, Fermat's last theorem was proven only for 3 exponents, 3, 5, and 7. So you may be thinking, oh, you mathematicians are too slow. What's happening? But we have some progress in the early 19th century. There was a proof was given for a particular type of prime number P, where just as an illustration, 5 is an instance of this prime, because if you multiply 2 with 5 plus 1, you get 11. 11 is again a type of this prime, because 2 times 11 plus 1, 23 is a prime, but 13 isn't, because 2 times 13 plus 1, which is 27, is not a prime. This is the first general proof. By that we mean that the first proof that you saw that is not proving for a particular number, not for 3, not for 5, not for 7, for a group, but it's for a group of prime numbers. Okay, so this was the first time we saw this. Who did it? It was presented by a certain Mr. Leblanc in correspondence to another famous mathematician, Carl Friedrich Gauss. There are many letters of their correspondence. First letters dated 1804, where Mr. Leblanc outlined his progress towards proving the theorem. Now, 2 years from 1804, something happened in Europe. Napoleon was invading Prussia, modern-day Germany, and the French army was storming through one German city after another. So Gauss is in trouble, basically. But Gauss received a special care from a certain general, guaranteeing his safety throughout the invasion. Then the general told Gauss that he owed his life to a certain Miss Germain. My French isn't so good, so if I mispronounce it, I apologize. Okay, then Gauss said, I don't know this person. I've never heard her name. So Sophie Germain is actually Mr. LeBlanc. So she, back in those days, women are deemed inappropriate to study mathematics. So she studied on her own, using her father's books. And at some point, she managed to correspond with famous mathematicians, including Gauss. And she was too afraid that if she said she were a woman, that no one would take her seriously. So she used a fake name, a male's name. Fortunately, us women these days don't have to do this anymore. Okay, so this prime number p with the property that 2p plus 1 is a prime is now known as the Germain prime. In 1850, Ernst Kummer improved Germain's result. But still, the final proof is far from done. Okay, so what next? The next progress do we have? There's not a breakthrough happening in 20th century. By 1978, Fermat's last theorem was proved for all primes less than 125,000. Oh, wow, that's a big improvement, right? How did they do it? The answer, brute force. Use computers. Use computers to test all possibilities. By 1993, computers could verify the theorem for all primes less than 4 million. But if you think 4 million is a big number, you're wrong. This is not enough. Even if supercomputers spend lots of time proving one value after another, they could never prove for every value of n, because this is a property of integer. The moment you said this is a big number, there's another one. There's another one, there's another one. We call it successor in mathematics. Okay, so we need a better proof, right? Enter two Japanese mathematicians called Taniyama and Shimura. Okay, they found that there's a link between two objects in mathematics, elliptic curves and modular forms. Don't worry too much about what they are. Just remember their names for now. Okay, Wikipedia can help you also after the talk. Okay, this is posed in 1955. And in 1984, you're probably wondering, what are these two objects and what are they doing with this theorem? There's a mathematician called Gerhard Frey who noticed a link between the conjecture and Fermat's last theorem. He did a clever trick, but there was a blunder in his logic. 2 years later, a mathematician named Ken Ribet finally gave a complete proof for this connection. So the connection goes roughly as follows. Any solution that could contradict Fermat's last theorem, saying that it's false, could also be used to contradict Taniyama-Shimura conjecture. Mathematically, this is the same by saying, if the Taniyama-Shimura conjecture is correct, then Fermat's last theorem is correct. So if you are able to prove Taniyama-Shimura conjecture, you're able to prove Fermat's last theorem. That's the story. Enter Andrew Wiles, whose name you might have heard. Okay, Andrew Wiles was obsessed with this theorem since his childhood. It's his dream that he one day will prove this theorem. He started his graduate study in 1975 at Cambridge, and in the decade prior to that, everything he's done studying mathematics is set so that he can prove the theorem one day. But eventually he set aside this obsession. I have his quote here. Let us read it together. The problem with working on Fermat was that you could spend years getting nowhere. It is fine to work on any problem so long as it generates interesting mathematics along the way, even if you don't solve it at the end of the day. The definition of a good mathematical problem is the mathematics it generates rather than the problem itself. Wise words, I must say. There are many mathematical objects that are invented because of someone trying to attempt a problem and fail. Non-Euclidean geometry is one of them. Okay, so Andrew Wiles went to study his PhD. His advisor was John Coates, and he advised him to study elliptic curves. You remember the name earlier from when we talked about Taniyama-Shimura conjecture. So after graduating from Cambridge in 1980, he became a professor at Princeton in 1981. And he was having a casual conversation with a friend, sipping iced tea in 1986, and somebody told him, hey, Ken Ribet has just proved there's a link between Taniyama-Shimura conjecture and Fermat's last theorem. And Taniyama-Shimura conjecture, if you remember earlier, has link between elliptic curve and modular form. Elliptic curve being something that Wiles know very well at this point. So he has a new obsession. He's set to prove the Taniyama-Shimura conjecture. After 6 years working on a problem, he proved a special case of the conjecture that was enough to prove Fermat's last theorem. Okay, so not the full conjecture, but enough to prove Fermat's last theorem. This happened in 1993. He worked in secret. Nobody knew that he was trying to prove Fermat's last theorem. There was a flaw in his proof, but eventually, after he's seeking advice from colleagues and so on and so forth, his final proof appeared in 1995. Okay, so 8 years working on this. Just a side note, the Taniyama-Shimura conjecture finally proven in 2001, the full version, by a group of mathematicians, most of whom are students of Wiles. Okay, so I'll get back to Andrew Wiles in a moment, but I want to mention somebody else in the story. It's the South African mathematician that's involved in this whole story. His name is Peter Sarnak. He's currently working in Princeton. He is a Wits alum, so he was here at some point on this campus, and he joined Princeton Math about the same time as Wiles, and they became close friends. In fact, he was one of the first few people that Andrew Wiles talked to about proving the theorem. So I have the excerpt from the documentary of Fermat's last theorem. Let's see the conversation, or rather their accounts by Wiles and Sarnak about that conversation when Wiles told him about the theorem. So Andrew Wiles said, I called up Peter and asked him if I could come around and talk to him about something. Peter Sarnak said, I got a phone call from Andrew saying that he had something very important he wanted to chat to me about. And sure enough, he had some very exciting news. Andrew Wiles said, I think you better sit down for this. He sat down, and I said, I think I'm about to prove Fermat's last theorem. Peter Sarnak said that he was flabbergasted, excited, disturbed, and finding it quite difficult to sleep that night. Because this is a big thing. It's been over 350 years, and we're about to prove the theorem. Very exciting. Okay, so finally we have a successful proof, Finally, after 358 years from its conjecture, Andrew Wiles proved the theorem in 1995. It took him 8 years to complete his work, and the proof was based on the works by many mathematicians before him. There's Taniyama and Shimura coming up with the conjecture, Ken Ribet, Frey, who saw the connection, Ribet, who finally confirmed the connection, and then Andrew Wiles proved enough of the Taniyama-Shimura conjecture to prove Fermat's last theorem. So to say that he's the only one responsible to prove the theorem is actually not very accurate. We owe our success to the people before us, and I think this is true for every mathematician. It's never just the work of one person; it's the work of people before us, also the work of friends around us, like Peter Sarnak to Andrew Wiles. A side note: I think the medal is named after Peter Sarnak. Well, yeah, one of the medals that would be handed out tonight. It's named after Peter Sarnak. So what I'm trying to say here is basically have this opportunity of this evening of having your peers, winners of this competition, get to know each other. Maybe one day you together will prove some big theorems in mathematics. And just to close, the proof uses techniques from a field called algebraic geometry. And this knowledge of mathematics did not exist in Fermat's era, so it was highly unlikely that Wiles's proof was the proof that Fermat claimed he had. And if you're curious how long the proof is, it's 100 pages long. So truly too large to fit in the margin. Thank you very much.
Wow, Edie, you absolutely spoiled us there. Thank you so much for that. And I think you'll all agree that maths is absolutely fantastic. It's a bedrock of so many disciplines. You've got physics, you've got core mathematics, you can go to geophysics, you can go to quantitative analysis, quantitative finance. There are so many things that one can use maths for. And it's so exciting to see everyone here in this room, because this competition was birthed 6 years ago. And we just said, we can, as Gauteng, start really developing incredible talents within a South African context, we can become a central place where maths talent grows. And now John's asked me not to name the person, but one of the International Maths Olympiad team members, I remember she's been involved in this competition for a long time. And it's just so exciting because I think, as you do these competitions, you start realizing what you can learn. You start being able to connect with different people, go and visit Phil in the Western Cape, who's an incredible teacher. And it's just so exciting. So I hope that you've been absolutely enthused by this. We're on to the team's awards. And the first team's set of awards, could I please ask Dr. Stephen James, and he's from computer science. He's just going to come and hand out the grade 4 to 5 awards. And while he's coming down, he'll just explain a little bit about these awards. So there's categories grade 4 to 5, grade 6 to 7, grade 8 to 9, grade 10 to 12. And where the universities come together, there's also an undergrad option. And what's so nice about this competition is we've taken away the idea that you have to pay to enter. So as you'll have noticed, it's a free competition. Number one, what that does is it takes away the need for admin. And number two, it means that anyone from disadvantaged backgrounds can enter for free. And I think in this country, that's what we're needing. We're needing to be able to just free the teachers, right? Because that admin of having to pay 20 Rand or whatever, no. Like I'm just over that. And just being able to let everyone, when we started 6 years ago, it was mainly around Gauteng that we had stuff like pretty locally and that kind of thing. And right now we're getting some of the best schools in South Africa, and any disadvantaged schools that want to participate are free. We've got people from Liberia, from Rwanda, from Botswana. This competition has got pretty big. I think we're going to keep it within Africa. I don't think we're going to go beyond that. But the fact that you guys are here is really, really something, because the competition's getting stiffer and stiffer. We've got the Western Cape teams that are here in full force. And well done to all of you. I just want to give everyone a hand.
All right, great. Thanks, everyone. I'm very excited to be here. Thanks to John for inviting me. So yes, I think we can get started with the awards, which is what everyone is ultimately here for. Okay, so let's talk about the winning schools for middle primary. So if I can ask the relevant teachers to please come up when your school appears. So first one is Mbizeni Combined. Okay. Next, Uelzen Primary School. British International Preparatory. Norcombe Park Primary School.
Stay there till all of you are done.
Right. Karo Serengeti. Global Combined School. Thanks. I think in the interest of time, we'll just have everyone come down. Otherwise, it will take a while. Yeshiva College. Law School Garsfontein. De La Salle Holy Cross College. suppose now we're into the top three. It's very exciting. So in third place, we have King David Linksfield Primary School. In second place, we have Trinity Preparatory School, Rampart Ridge. Oh, sorry. And Somerset House. Cool. St. Henry's Marist College. Corpora Primary. Sunlands Primary. Windhoek Gymnasium Private School. Red Hill Primary School. And I think now is the final overall winner, which is Sweet Valley Primary School.
So just a note about those quintile winners. So South African schools that are not private are divided into quintile 1, 2, 3, 4, and 5. So I think quintile 5 are your Model C schools, your old Model C schools. And it goes pretty much the lower the number, the less income that school has. And so for us, that is the true measure of a school being disadvantaged. And when a school like that starts performing, you know you've got some special teachers. So I think we should just give another round of applause. So without any more ado, we're going to hand over for the grade 6 to 7 team prizes, Dr. Amani Ngowi, who is from the School of Applied Mathematics.
Hi, everyone. Hi, everyone. Before I start, I'll just have to ask, I'm not quite good with pronouncing certain names, especially African names. So yeah. So the first school is Uzen Primary School. Then we have St. Catherine's Convent, 10th place. Have Global Combined School, 9th place. King David Linksfield Primary School, 8th place. British International Preparatory, 7th place. Rudin School, 6th place. St. John's College, Preparatory, 5th place. JEP High Preparatory, 4th place. Lesco Tagaport, 3rd place. Windhoek Gymnasium Private School, 6th place. Trinity House Preparatory School, Ranfat Ridge, 2nd place. Somerset House, 4th place overall. Sweet Valley Primary School, 3rd overall. Glenwood Preparatory School, 2nd place. Red Hill Primary School, 1st place.
So if you're a bit confused about the numbering, there's kind of like two scales going on the whole time. So there's a top 10 in Gauteng and a top 10 in the entire competition. So that's what that means. I now hand over for the grade 8 to 9 prize giving. It's going to be Dr. Pravesh Ranchod, who's from the School of Computer Science.
So I'm not Pravesh, but I should probably say this is the first award which we have named after someone who's been a big force in sort of Wits mathematical history. And this is named after Paul Laridon, who wrote a very good series of school math textbooks and very involved in maths education for a long career. And over to Pravesh.
Hey everybody, so the junior secondary prizes. The first school we're going to mention is a notable quintile 2 school, which is Kitsong High School. We also have a notable quintile 3 school, Nkobo Village School, senior secondary school. I was like, and then in 10th place in Gauteng, we've got Yeshiva College. In 9th place in Gauteng, Eduplex. In 8th place in Gauteng, Woodhill College. In 7th place in Gauteng, Radford House. In 6th place in Gauteng, St. Catherine's Convent. In 5th place in Gauteng, St. Stithian's Boys College. In 4th place in Gauteng, King David Victory Park High. In 10th place overall, we've got a tie. We've got Bishop's College and Stellenberg High. In 3rd place in Gauteng and 9th place overall, we've got Parktown High School for Girls. In 8th place overall, Perel Palais. In 7th place overall, Maru Apula. In 6th place overall, Parklands College. Then in 5th place overall and 2nd place in Gauteng, Red Hill School. In 4th place overall, the Ambassadors College. In 3rd place overall, Petit Seminaire St. Vincent Ndera. Excuse my French. In 2nd place overall, Westerford High. And in 1st place overall and 1st place in Gauteng, St. John's College.
Okay, congrats everyone. It's really good to see in this division in particular. We had winning schools from Nigeria, the Ambassadors College, Rwanda Petit Seminaire, Marapula from Botswana, and a local school right in first place. So our next group of awards is the Team Award for grades 10 to 12. And it's named after the late Professor Peter Fridjon, who was in statistics, and his brother, Michael Fridjon, is going to say a few words about Peter, and will then present the awards on his brother's behalf.
And I have to say, Peter Fridjon was one of my favorite lecturers, so it's wonderful to have his brother here with us today.
Thank you very much, and thank you for the opportunity of being here. My brother was fanatical about numbers and maths. From a very early age, he'd say things on your birthday like, "You've been alive for 322 hours, 576 minutes, or whatever he happened to have calculated at that moment. If you ever challenged him, he was always right. It was most frustrating to be his younger brother, but also very entertaining. And his career in math started as school teacher, and then he came to the university, which is where he completed his career. And I know he'd be very proud to be here tonight because he really believes in the importance of mathematics and the pleasure it gives so many people. So, ready to go if I'm doing the announcing, but I have a very blank screen. Just start. Right, so the first is the Tengwe High School Notable Quintile 3 School. And then the Shri Bharat Shah de Mandir Independent School, 10th place in Gauteng. Eduplex, 9th place in Gauteng. Parktown High School for Girls, 8th place in Gauteng. Seventh place in Gauteng goes to St. David's Maris Tsenanda. So now, winning schools senior secondary, 6th place Gauteng is Radford House. Fifth place Gauteng, Cornwall Hill College. 10th place overall, 4th place in Gauteng, Red Hill High School. Ninth place overall, St. Henry's Marist College. Eighth place overall, Westerford High. Seventh place overall, 3rd place in Gauteng, King David High School, Linksfield. Second place in Gauteng and sixth place overall, Yeshiva College. Fifth place overall, South African College High School, SACS. Fourth place overall, Parel Valley High School. Third place overall, Rondebosch Boys High School. Second place overall and first place in Gauteng, St. John's College. And the first overall, the Ambassadors College. Congratulations, everyone.
So that concludes the team awards.
Wait, just take a photo with John.
So thank you, Michael. That does conclude the team awards, the school awards. And before we move on to the individual awards, we have a word from our sponsors. First up is John from Allan Gray, who will be talking about life at Allan Gray. We are very, very happy that they agreed to help sponsor the competition. It allowed us to run a training camp in the July break, which many of you attended, and which we got to have a lot of the top performing quintile learners attend, which I think really does, help to build the region mathematically. So, over to you, John.
And I'd just like to add that they were able to bring 15 disadvantaged kids who've been seen in the competition and who've been really, really good. And so we're really, really spoiled to have you, Jacques. So thank you so much.
Thanks. Hi, everyone. When I was 16, a friend of mine asked me this question. He asked, where do you see yourself in 10 years' time? And I had absolutely no idea how to answer this. I couldn't imagine myself working or married. At that age, in my case, the world was divided between scholars and students and old people. And when you start working, you're in this other group. And guess what happened? Time passed, and here I am. And if you're 16 or 13, that kind of age, the same thing's going to happen to you. And at some point, you're going to be 26 and you're going to be looking to join the professional world, or you may even be looking for a job one day. And I'm here to talk tonight about this transition, right? This, for many of you, what will be the next 10 years, and some things that you might not be expecting, or some things I wish I had known when I was 16. And I'm also going to be talking a little bit about the Allan Gray investment team. So my first little bit is about paths. When you go from university to working, it's like you're going from being on the highway to hacking your way through the jungle. And what do I mean by that? Before then, your path is pretty clear, right? It's obvious. You go from primary school to high school, and then the vast majority of you are going to go to university. But after that, actually, it's not clear at all. And you also have these very nice hierarchies when you're at school. Everyone knows where you are academically in the class. Soon, everyone's going to know where you are in the Olympiad. Everyone knows if you're first team sport or second team sport, or if you're like me, a permanent reserve. And everyone knows if you're a leader at school, you're a prefect. And all that ranking kind of disappears after school. And that's actually quite a tough transition. And some people fail to make the transition. They spend their life trying to build what they think is the perfect CV. Or some people live by this motto, whoever dies richest wins. You know, they look at money for some kind of ranking of where they fit in society. There's a book by Jonathan Haidt, The Coddling of the American Mind, where he speaks about what it takes to get into Harvard nowadays. And a lot of these kids, from an early age, they've got coaches and tutors, and they're working towards this goal. They even come and do something like work in Africa with kids, so they can put that on their CV and improve their chances of getting into Harvard or Princeton or those prestigious universities. And then guess what happens? A lot of these kids, they spend their first year at university competing to get into the most prestigious societies. They're so used to like having the structure imposed on them and conforming to what they perceive to be a successful career path. They can't get out of it. And I would recommend try not to be that person. It's much more exciting and fulfilling to make your own path through the jungle. I've made this analogy of a journey, right? But you know, you're following a highway and then you're following a path through the jungle. But the problem with using this analogy for life is that usually with a journey, you're keen to get to the end point at some stage. Whereas with life, the end point is death. And I mean, I'll save my views on the afterlife for another speech. But another alternative analogy you could use is one of a picture. And you're busy drawing the outlines of your picture now. And every day you're busy filling in bits of what is hopefully going to be your masterpiece at some point. And rather than trying to get to the end of a journey quicker than everyone else, maybe think about it this way, right? Trying to paint the most beautiful picture you can. And every stage of life is important. Okay, that's the soppy bit of my speech. I wanted to talk about some things I wish I'd known. The one thing is, not all education is necessarily good. Or the way Elon Musk put it in a tweet a couple of months ago, don't confuse credentials with education. And there are lots of things, I mean, obviously it's a great idea if you can study at university, it's usually a good return and that sets you up well for further study or finding a job. But lots of people are going to try and sell you a credential. And maybe it's a CA South Africa or becoming an actuary or becoming a CFA charter holder or doing the CIMA exams. And not all of these are necessarily the best use of your time. You've got to weigh up these things with alternatives, right? You could be learning Latin, you could be reading Shakespeare, and employers aren't necessarily looking for a list of credentials. They're looking for people who are going to be good at what they do and are competent at their job. And sort of a list of things on your CV is not necessarily going to be the best solution to this problem. So another thing which I wish I'd known is your day-to-day is actually what matters. And don't be fooled into doing something which sounds glamorous. So a lot of people say, for example, they want a job where they can travel for work. And I always ask them, do you like spending a lot of time in confined spaces? Or do you like being exposed to jet lag? I tried going to bed at 2 p.m. 1 week and waking up at 10 p.m. and just living like that. It's not much fun. And that's, if you travel across time zones, that's what's going to happen to you. Or some people say, they want to be investment bankers. That's the prestigious thing to do after university. And then I ask them, do you enjoy reading legal contracts at 10 p.m. at night? Because that's what investment bankers do. And some people really do. I mean, I enjoy reading annual reports for a living, but just be sure that this is actually the day-to-day thing that you want to be doing before you choose that as a career path. I interview lots of people. They're very keen to join the Allan Gray investment team. They really want to be investors. They want to be like Warren Buffett, but they've never opened an annual report. They've never bought a stock, and some of them have never even read a business book. So just don't follow what you think you want to do. Just try and find out what it is actually that goes on at the place of work. And then my last thing I wish I'd known is, it sounds great to work for a young team and it sounds very dynamic. But actually, if you're choosing a place of work, you want to mix. Because when I started working, I realized that the people I want to spend time with are actually the older people who've been there for a while, and you can learn something from them, and they've got experience and they've got war stories. So then I just want to say a little bit about the Allan Gray investment team. So what do? We spend our time writing reports on listed companies, valuing businesses, and trying to see if we can buy those listed companies for less than what we calculate they're worth. And this often involves solving tough business problems. So they are not like Fermat's last theorem, but the kind of things we're working on is, well, how many cars are going to be electric by 2035, and what does that mean for oil consumption? Or what are artificial diamonds going to do to the luxury goods market? And what does that mean for Richemont? Is Transnet going to be able to pay back its debt? That's kind of, it's also a tough problem with lots of dimensions, and you want to have some view on the future. There's lots of room for debate. I really enjoy these problems. I think they're very interesting. We've had several people join us who have previously been Maths Olympiad winners, who finished their BSc maybe. I studied BSc at university, and they've had very good success on the investment team, and they've done well. So if this is something that appeals to you for one day, maybe it's still a long time before you got to think about this, but I promise you the time's going to come around. Have a look at our website. There's an investment team tab on the careers page. I wrote some things there about what it's like to work at Allan Gray. And if you have further questions, I'll be around afterwards. Chat to me or find me on LinkedIn. Send me your questions. We're interested in hiring people like you that have a talent for mathematics and hopefully an interest in life and business problems. So thank you very much for the time.
Thanks, John. That was very interesting, and agree with large swaths of almost all of that advice. One thing I will add is that if you're competing to get into Harvard, you're probably not going to Wits. Come here, guys. I mean, that's it's the Wits contest, so I'm going to say that because it's true. Our next sponsor is John, and call on Lisa Moore to say a few words for them. I mean, you're all getting calculators, so I think she will talk about how to use them. And remember, you're not allowed to use them on the actual paper.
I lost my notes. Okay, awesome. Hi, everybody. So I'm Tel. I've been working for Sharp for a very, very long time. And I used to teach maths before that. And so I even see some familiar faces here, and I'm really excited. Hi, guys. So I just wanted to say a couple of things. And the first thing is that maths is everywhere. And we've heard this throughout all the talks today. Maths really is everywhere. From going for a 3D baby scan, you know, okay, you guys who don't have babies. If you get injured when you're doing sports, you have to have an ultrasound. They use maths to figure out how to see the different layers through the skin, which is really cool. I know that's a far out example. And maths is a language, and we all speak it, which is really cool. We can go anywhere in the world, and if you look at your calculations, or we look at those Greek letters that we use when we get to university, we can go, oh wait, I understand that. I mean, when I looked at that fluid mechanics formula from Jane Hutchinson, I was like, oh wait, hang on, I sort of see what's going on there. There's some differentials, and there's some sign, and there's some other stuff, but it's universal, and you can go anywhere with it, which is really cool. Maths is also all linked. So when we talk about fluid dynamics, those basics, that sign and that differentiation, that's also part of where you're going in school right now. If you think about your sequences and series, your patterns, your number patterns, if you think about compound interest, all of that is linked. They are all patterns. And how you solve things is by identifying that pattern and working out how to represent it with numbers. Okay, so I want to tell you a little bit about the calculators you guys are going to get. So there's two. So this one over here is our W506T. It's for your senior winners, so it's for the high school guys. Thank you. And it has over 600 functions on it. It does things like integrals, differentials. It does matrices and complex numbers. It's absolutely amazing. It helped me get through my applied maths degree. I'm not gonna lie to you. So it really does a lot of things from statistics where there's statistical distribution. So if you're doing AP maths, it will really help as well. And then for the juniors, we have the 535. So they come in blue and red and white, but I didn't send the white ones because boring. But these ones also have a maths game on them. So if your mental maths, you know, when you're bored at the end of your Afrikaans exam, or was that just me? Then you can play on the calculator and do mental maths. Although you're probably all really good at it and you're probably smarter than I am. So there's that. Then I just want to say to the parents and teachers who are here, you guys are the reason that these kids are excelling, in part. You've put in a lot of work and you've done the carting and the carrying and the tutoring and the extra Wits things on a Wednesday. And so we really appreciate that you've put in all of this extra effort into the kids. Teachers don't often get recognized for what they do in school and all the extra effort that they do. So I'm saying to you now, well done, thank you. What you do matters a lot to everybody, including the students and the hundreds and hundreds of students that you're going to influence throughout your career as well. Then I want to tell you a little bit. I want to tell you about a project that's very close to my heart. It's called Future Fund. So what we did is we created this fund, and basically we are trying to get calculators into schools that can't afford to buy their own calculators. And so what we'll do is any donation that comes in, we will match with the equivalent donation of a calculator. So if you purchase a calculator for 400 Rand, then we will add a second calculator for 400 Rand to your donation. So that means 2 kids get a calculator for every donation that you make. And so what we've been doing is we've been working with Sandringham High School, that's in Edenvale. We started in 2022, and their pass rate for 2021 was 33%, which is for maths, which is frightening. And I'm sure you guys don't come from schools where that's the pass rate. But this school was really struggling. And so we approached them and we said, can we do something? Can we help you? And so we gave all the matric students calculators. We taught them how to use the calculator. And then I spent once a week with them doing extra maths with them. And I got pregnant in 2022, so I had a baby. So I only got to see them up until July. And the pass rate at the end of 2022 was 43%. So that, if you work it out, is an increase of 33% on their student, which is awesome. So we're doing it again this year, and I'm really excited to see my students actually wrote on Monday. So now we hold thumbs and see how they're doing. But if you'd like to be involved in the Future Fund, please do get in touch. John has my number. The maths teachers that I see in the crowd, and if you are a maths teacher, please come and chat with me afterwards. I'd love to get to know you and maybe help you out in whatever journey you're doing as well. I've lost my notes, give me a sec. Then 2 things. If you are looking for extra resources, we have a website called maths@sharp.co.za. It's got free worksheets from grade 8 to 12 for maths, math literacy, and technical maths that you can download and use. There are videos on our YouTube channel. So take a peek and see if you are looking for extra help. Obviously not you, but any kids that you are tutoring that you need help with, and for the maths teachers as well, because there's always that one kid who just needs that little push. And so that's what we're there for as well. And then to the students that are getting new calculators. Now, I've been at Sharp for 12 years. So here's my challenge to you. If you can find something new on the calculator, send me a video. You can contact me through Maths@Sharp. There's a contact us page, and I'll email you back and you can send me back a video. If you can send me a video of something new that I haven't seen, then I will sponsor calculators for a class at your school. Deal? Cool. All right, guys. Enjoy the rest of the session.
Wow, Salita, that was really something. Thank you. Now for what you've all been waiting for, it's the individual prizes. And we're going to have Jacques come and announce the grade 4 to 5 individual prizes. Thank you, Jacques.
Okay, I'm back. Samuel Schultz. Shall I read them? I'm just gonna go. Samuel Schultz, shall I read name and school or just name?
maybe name and school. And
Okay.
just a note that if you do well in the top 10 Gauteng and overall, you're going to get 2 medals. Okay.
Samuel Schultz, Wilson Primary School. Jamie Siegel, King David Linksfield. Timothy Hodgson Jarvis, De La Salle, Holy Cross College. Rachel Shen-Yu, King David Linksfield. Andrew van der Westhuizen, for Hartsfontein. Hurui Chen, Trinity House Preparatory School. Yusiso Nduze, Nduzeni Combined. Callum Biggs, Sweet Valley. Daniel Malach, King David Linksfield. Venkata Siva Idara, Star College Durban. Tanika Dalal, Red Hill. Thank you, Furi. Fintuk Nasir. I'm going to start going a bit slower. Zachary, geez, this is a tough one. Sujuka, Kira Edenvale, 4th place overall, 3rd place Gauteng. Ivy Williams, Sweet Valley Primary School, 3rd overall, best draw overall, best fruits overall. Jonah Kritzmer of Red Hill, 2nd place overall, 2nd place Gauteng, best fruits. And I think we have the winner next. Ethan Harris, Red Hill, 1st place. Well done.
Okay, congrats, guys. A reminder that between sort of February and October, we have Wednesday night training, and you superstars at this very young age. We love to have you around to get better at this and sort of push winning IMO and PAMO levels when we get to high school. So please consider coming and hang out on them if you can. Now we're moving on to the upper primary, that's grade 6s and 7s, and Dr. Johnson will be presenting them.
All right. So notable quintile 3 learner is Avril Masuku from Global Combined School. Then in 10th place in Gauteng, it's Letian Lee from Red Hill. In 9th place from Gauteng, Sarah van Gotberg Cohen from Auckland Park Preparatory School. Then in 8th place, Gauteng, and the best girl in Gauteng. So we've got a best girl for each of these categories. But we've got Navira Chana from British International Preparatory. Woo. All right, in 7th place in Gauteng, we've got Kui Han Jang from Red Hill. All right, in 6th place in Gauteng, we've got Matthew Mala from King David Linksville Primary School. And into the overall placings, we've got 5th place Gauteng, and 10th place overall, Joshua Sadeo Red Hill. And just a note about the medals. So in 1st place, you'll get a gold medal. If you're in 2nd to 4th place, you get a silver medal. And from 5th place to 10th place, you get a bronze medal. In 4th place, Gauteng, and 9th place overall, we've got Thomas Brown from Red Hill. All right, in 8th place overall, we now have Adam Rousseau from SA College High School, so from SACS. And 3rd place over in Gauteng, 7th place overall, we've got Yi Ching Ning from Red Hill. Very good, Gauteng coming 7th place there. Then in 6th place overall, we've got Rahul Govender from Glenwood Preparatory School. I think that's in Durban, if I'm not mistaken. Then in 5th place overall, Glenwood Preparatory School, we've got Daruk Kumarasamy. Then 4th place overall, Sweet Valley Primary School, that's Cape Town, we've got Finn Williams. And then in 3rd place overall, and the best girl overall, is Olivia Castleton from Somerset House, also Cape Town School. And we've got a Gautenger. So in 2nd place overall, 2nd place Gauteng, best proofs overall, best proofs Gauteng, we've got Ku Yuan Sun from Red Hill. So just to note that another way that the competition differs from many others is that we're trying to get kids into writing proofs from a fairly young age. It might not be the hardest questions, but the idea is you've got to get used to structuring things and realizing that's also part of maths, not just like this multiple choice, eeny, meeny, miny, mo. Then in 1st place from Gauteng, woo! And 1st place overall is Jen Xuan Liu from Red Hill. And if you're not sure about which place your child came or anything, you're welcome to come afterwards and just double check on the system. Now, the grade 8 to 9 individual awards are named after Professor John Knopfmacher, the late Prof. Knopfmacher, who had a huge imprint on this university. And to come and hand out those awards is Professor Arnold Knopfmacher, who was also one of my lecturers, who was absolutely fantastic. He'll also then just talk a little bit about his dad. Where are you, Prof. Knopfmacher? Oh, wonderful. Merci, Knopfmacher. Just please carry down.
Hi, it's a pleasure to be here this evening to present a prize in honor of my late father. He was a mathematician back in the days when you had little opportunity to study here in South Africa. So in order to do his PhD degree, he went across to England and came back with a PhD. And in those days, PhDs in mathematics were not common in South Africa. So he said when he started his job in the maths department, probably the maths department had around 30 members of staff, but back in those days, only he and the head of department actually had PhDs. It was not expected back in those days. Of course, everything has changed these days, and if you're going to be a maths lecturer, even at the bottom of the scale, it's now understood that you will have to do a PhD. But the good news is that there are plenty of opportunities to study for even a PhD degree here in South Africa. So you don't have to go anywhere to do this. Anyway, I'm going to now talk about the winning learners in junior secondary. First is Badila Masweli, Pakaza High School. Um, 10th place Gauteng, Kai Bick from King David Victory Park High. Ninth place Gauteng, Charles Janse van Rensburg from Hoërskool Waterkloof. Eighth place Gauteng, Aaron Dorfman from Red Hill. Seventh place Gauteng, Nicholas Schmidt, St. Stithians Boys College. Sixth place Gauteng, best girl overall, best girl in Gauteng, Demira Roop-Narain from Parktown High School for Girls. Fifth place Gauteng, Ziru Lee, St. John's College. Is it still me doing the? Okay, so these are the winning learners junior secondary. Fourth place Gauteng, Jason Shee from St. John's College. 10th place overall, Virtual Bikel, Petit Seminar St. Vincent Madeira. Third place Gauteng and 9th place overall, Zeyun Lee from St. John's College. 8th place overall, Liam Baruch from Fulls Math Club. Seventh place overall, 2nd place Gauteng and best proofs Gauteng, Ashar Johnson, Trinity House High School, RPR. Sixth place overall, Ben Marie, Westerford High. And now winning learners junior secondary. Fifth place overall, Jeremy Little, Bishop's College. Fourth place overall, Noah Rasso, SA College High School. Third place overall and first place Gauteng, Noah Greenblatt from David High School Linfield. Second place overall, best proofs overall, Ellie Williams, Westerford High. First place overall, Yana Key, Westerford High. Am I still doing or you? Good. Okay.
Okay, so our next and final two sets of awards are for grade 10 to 12 learners and for university learners. Sorry guys, more technical difficulties. Okay, we're back. So our next two sets of awards are also named. There's the grade 10 to 12 one, which is named after Prof. James Ridley, and the first 3 years of tertiary education one, which is named after Peter Sonak, who spoke about a bit of your talk and his involvement with some of the biggest things that happened in maths in the last century. So when Prof. Sonak was an undergraduate here, one of his main mentors was Prof. Ridley, who unfortunately could not make it tonight. So whenever I've run into American mathematicians and we sort of mention I'm South African or that I'm from Wits, and these were people who I'm in their own right aware of, they go, oh, you're from Wits, or you're from South Africa, you must know Peter Sonak, and at the time I didn't. And when I was a postdoc and he was a grad student, when he was a postdoc and I was a grad student, or anything like that, or I was a professor and he was, whatever the connection where they were at the same university at the same time, then sort of start talking about this, beloved mentor with awe and really quite impressive. And the only other time I've heard anyone talk like that is when I finally did get to meet Peter. I tell this every year. And he said, oh, you're from Wits. Right, do you know James Ridley? When I was an undergraduate, and I tell this every year because it's true. And whenever I hear Prof. Ridley talk about anything mathematical, I kind of go, oh, wow, that's how plus works. I never really understood it. I mean, even the simplest thing I find just new links and appreciation for whenever I hear him talk about it. So I'm going to call on Pravesh to read the names for his award. And obviously, you've already heard about Peter, so I think after that, Sal will present the undergrad winners. There's also going to be food outside afterwards, so do encourage you to stick around. I can only do so much myself, so please stick around.
Okay, so let's get going with the winning learners in the senior secondary category. In 10th place in Gauteng, we've got Nicholas Delport from St. David's Marist Inanda. In 9th place in Gauteng, we've got Rex Tinashe Makosa from Horizon. In 8th place in Gauteng, we've got Amina Mayat from Parktown High School for Girls. In 7th place in Gauteng, Franz Sneeman from Radford House. In 6th place in Gauteng, Joshua Andrews from Cornwall Hill College. In 5th place in Gauteng, Harrison Hay from Crawford Santon. In 4th place in Gauteng, Angus Clark from St. John's College. In 3rd place in Gauteng and 10th place overall with the best proofs in Gauteng, Noah Jacobson from St. John's College. In 9th place overall, Jared Slater from Parel Falay High School. In 8th place overall, Yana Rousseau from Jim Fouchier High School. In 7th place overall, Hamza Lunat from Weinberg Boys. In 6th place overall, Ellen Grant Smith from Westerford High. In 5th place overall and 2nd place in Gauteng, Caleb Johnson from Trinity House. In 4th place overall, 1st place in Gauteng, the best girl in Gauteng and the best girl overall, Yan Zhu. In 3rd place overall, Moyed Baleg from Falls Math Club. In 2nd place overall with the best proofs overall, Yukyum Kim from Falls Math Club. And in 1st place overall, Akinola Mofifolua from the Ambassadors College. Cool.
Perfect. Let's give them another round of applause. Now, how many of you know that your problem-solving ability doesn't just switch off when you leave school? And many other competitions just say grade 12 is the end and now you just start studying. So one of the most exciting things for me about this competition is when you get to first university, second university, you still, your content matter gets a little bit more, but you still have to try and figure out how to apply it in a problem-solving type of way. So in 10th place in Gauteng, we've got Darren Hill from the University of Pretoria. In 9th place in Gauteng, we've got Brian Mayala from the University of the Witwatersrand. In 8th place in Gauteng and best proofs in Gauteng from the University of Pretoria. And neck, we've got 7th place Gauteng, Mohammed Uthman from University of the Witwatersrand. All right, in 6th place from Gauteng, we've got University of Pretoria, Michael Dregmeyer. And in 5th place from Gauteng, from the University of Pretoria, we've got Franco Prince. All right, from the University of the Witwatersrand, in 4th place in Gauteng, we've got Ramiz Abdul. Then Lene Crawford from the University of Pretoria comes 3rd in Gauteng and is the best girl in Gauteng. All right, in 2nd place Gauteng and 10th place overall from the University of Pretoria, we've got Gerlo Teron. And in 9th place overall from the University of Cape Town, we've got Matthew Dean. In 8th place overall from Stellenbosch University, we've got Carlo Anton Grobbelaar. In 7th place overall from Stellenbosch University, we've got Kerry Jean Correll. In 6th place overall from Falls Maths Club, we've got Aidan Conradi. 5th place overall from UCT, we've got Jason de Villiers. In 4th place overall from Stellenbosch University, we've got Jean-Michael Waite. Then in 1st place, Gauteng, yay, and 3rd place overall from the University of Pretoria, we've got Zerwig Zelanga. In 2nd place overall from UCT, we've got Jordan Hugh. And 1st place overall, best proofs overall, and best girl overall, we've got Danielle Steyn from Stellenbosch University. So in conclusion, I just want to say thank you to each of you for being here. I think it's been an absolutely magical, sparkling evening, and I think the talks were absolutely fantastic. I want to give a big thank you to Dr. John Karib, who's a lecturer here. He has done such an amazing job in getting all the entries and making sure everyone could write and making sure the papers got set and making sure the prize giving got sorted. And of course, last but not least, that there's lekker snacks outside. So I hope you guys can all enjoy. Thank you. And thank you, Pravesh, for everything.
Thank you. No health teacher came for the main primary. My son took his copies, and I get to get a Sure. It's a genius.
Could I ask that all the people who gave speaker and who were speaking at the front just come? Let's just get a group photo if that's okay. Thank you. Pardon? Okay, and the speakers will meet you outside by the snacks after we've taken a photo. Thanks.
Oh, that's
Perfect.
Of my school's results.
Alright. Which category are you in?
Upper primary schools, ne?
Do we not? We'll put them on the website, right?
Yeah, but I didn't announce them. Darling. You want the schools, eh? Okay. What was your score?
Yeah. There we go. 8 overall. Should be high. Thank you. Here's my school.
Okay. Okay.
We are very poor quintile 5, sorry. But our kids come here every
Oh, that's brilliant.
for the last couple of years. Well done, good job.
Thank you so much.
I'm just gonna.
Okay.